Good morning everyone. Today we are going to study the chapter Light. Chapter 10 Light, Reflection and Refraction. We know that light is a form of energy and it excites sensation of vision, etc. we have studied in our lower classes, and also we studied that light travels in straight line known as rectilinear propagation of light. Anyway, light shows dual nature, that is particle nature as well as wave nature. About this you will study in your higher classes. Now, in this chapter, we are going to study two important phenomena shown by light, that is reflection and refraction. Now, first, what is reflection? Reflection of light means when light strike on a medium, different things can happen. Sometimes it may pass through that medium, or sometimes it may be absorbed by the medium, or it may be bounced back or reflect back. That is according to the nature of the medium. If the medium is transparent, it can travel through that medium, the light can travel through that medium. And if it is an opaque medium, either it can be absorbed or it can be bounced back. Now, this absorption or bouncing back depends on that nature of that surface where the light strike. If the surface where the light strike is highly polished surface, most of the light falls on that surface get bounced back. That we call as reflection. So reflection means bouncing back of light on striking a highly polished smooth surface. Now, mirror is a surface that is highly polished surface, and on mirror, when light strike, most of the light fall on that surface get bounced back. So, most of the light get reflected back when strike on a mirror because it is a highly polished surface or smooth surface. Then, in our previous classes, we studied about the mirror, the one type of mirror, according to the surface of this reflecting surface, two types of mirrors are there. One type is that the reflecting surface is a plane surface, which is known as plane mirror, about which we have studied in our previous classes. Whereas the other one, where the reflecting surface is a curved surface, they are known as spherical mirrors. Just we can recollect what happens when light strike on a plane mirror. When light strike on a plane mirror from any object, that object's image is formed. The characteristics of the image formed are: the image will be seen inside the mirror. That means a virtual image is formed. And also when you see the size of the image formed, we can see the image is of same size as that of object. And the distance of the image from the mirror will be same as that of the object from the mirror. And more importantly, the image formed in a plane mirror is always laterally inverted. Left side can be seen right and right side can be seen as left. So that is lateral inversion. About this we have studied in our lower classes. This is the way in which image formed in a plane mirror. Now, so that bouncing back, reflection is known as the bouncing back. Now, before moving to the topic that is spherical mirrors, we can see that the reflection follows it obeys certain laws known as the laws of reflection. That means a smooth polished surface can be represented in such a way, that is, the line shows the opaque surface, whereas the opposite side of that lined surface is the polished smooth surface, which is acting as a reflecting surface. Now, if a ray strike on that surface, smooth polished surface, that in that ray which is striking on the mirror, imagine this as a mirror, and if the ray strike on that mirror in such a way, that ray is known as an incident ray. Now after striking on that, it bounces back, it gets reflected back, and this the ray that is coming back after striking the mirror is known as a reflected ray. So this is incident ray and this is reflected ray. Incident ray and reflected ray. If we draw a perpendicular to the surface, a straight line perpendicular to the surface, that is known as a normal. This is a normal to the surface. Now we can see here two angles formed, that is the angle formed by the incident ray and the normal is known as angle of incidence, and the angle formed between the normal and the reflected ray is known as angle of refraction. So these are the two angles we are considering here. The angle formed between the incident and normal is angle of incidence, angle I, and the angle formed between the reflected ray and the normal is known as angle R. Now the perpendicular line is known as the normal. Now the laws of reflection says that always this angle of incidence will be equal to the angle of reflection. That is the first law. First law states that angle of incidence is always equal to angle of reflection. Second law states that the incident ray, the reflected ray and the normal all lie in the same plane. That means when the light strike on the surface and get reflected back, and when we draw the normal, this everything will be lying on the same plane. Light cannot bend and travel to another plane. So it always lie in the same plane. So these are the two laws of reflection. The first law states that angle of I is equal to angle of R, and second law states that the incident ray, the reflected ray and the normal lie in the same plane. So all the light rays that is undergoing reflection obeys these two laws. Now moving to the next type of reflecting surface that are known as spherical surface, and the reflecting surface are called as the spherical mirrors. Spherical mirror means the reflecting surface is a curved surface, and the curved surface can be two ways formed. It can be formed in two ways. If the reflecting surface is curved inward, it is known as concave mirror, such as if we draw that reflecting surface like this surface is that opaque, and the other surface that is curved inward. This curved inward surface acts as the reflecting surface. So the mirror in which the curved inward surface acts as the reflecting surface, then the mirror is known as a concave mirror. Whereas if the reflecting surface is bulged outward like this, here the reflection takes place from this surface, the outward bulged outward or curved outward surface. The outer surface is acting as a reflecting surface, then it is known as convex mirror. So spherical mirrors are of two types, concave mirror and convex mirror. So these two are spherical mirrors. Spherical mirrors are of two types, concave mirror and convex mirror. So we can imagine, we can understand it easily. Concave, from the word itself we can understand cave means curved inward, cave. So if the cave surface is the reflecting surface, that is known as a concave mirror. Now we can see some terms related to these spherical mirrors. Some common terms are there that are related to these spherical mirrors. Since the spherical mirror is a part of a hollow sphere, it's a part of a sphere, we can understand that when we imagine it as a sphere, we can imagine that this sphere is having a center. The sphere has a center, and that center we can call as the center of curvature C. At the same time, the center of this reflecting surface, is known as pole or P. So P or pole is the center of reflecting surface. Center of reflecting surface is known as the pole, that is denoted by the letter P. And imagine this mirror as a sphere, then that sphere is having a center. That center of the sphere of which this mirror becomes a part is known as center of curvature C. So pole is denoted as P. Now C, that is center of curvature. Center of curvature. So P, that is the point, is there on both type of mirrors, convex mirror as well as concave mirror. And this is also a part of spherical surface, so there will be a center of curvature here. The difference is here, center of curvature for a concave mirror lies in the left side or on the same side, whereas center of curvature of a convex mirror lies on the opposite side of the reflecting surface. In case of concave mirror, it lies in the same side of the reflecting surface, whereas in a convex mirror, the center of curvature lies on the opposite side of the reflecting surface. So here is the center of curvature C. An imaginary line that passes through this center of curvature and pole, that is known as principal axis. So here also there is a principal axis that runs along with that runs through the P and C. So that is principal axis. So another term, principal axis is an imaginary line that passes through the center of curvature and pole of the reflecting surface of the mirror. So the next thing is that imagine a parallel beam of light strike on this mirror. If a parallel beam of light strike on the concave mirror, after striking the mirror or after reflecting from the mirror, these rays passes through a common point on the principal axis. It bounces back and it passes through a common point on the principal axis. That common point is known as principal focus F. When a parallel beam strike on the mirror, after reflection they passes through a common point on the principal axis, on the principal axis, and that point is known as the principal focus F. Principal focus or F. Principal focus. Now in case of convex mirror, if a parallel beam strike on this mirror, here in concave mirror what we saw is after striking they converge, they came together and meet at a common point. But in case of convex mirror, when the rays strike on the mirror, after reflection they do not come closer, instead they move away, they diverge. So this mirror is also known as diverging mirror, whereas concave mirror is called as a converging mirror. Here the light rays reflected back, diverge away. And if we extend these reflected rays, if we are extending these reflected rays back, we can see that they appear to come from a common point. They are not actually meeting, they appear to come from a common point on the principal axis. That is known as the principal focus for a convex mirror. So in concave mirror, the principal focus is the point where the light rays actually meet after the reflection, whereas in case of convex mirror, principal focus is that point where the rays of light appear to meet.